Um, so we're gonna talk for the next little bit about graphics in Blink and in Chrome, and this could go a lot of different directions, but we want to sort of give some context for where we are today first. I think this part of the code base is something that is sort of scarcely understood outside of like the team that works on the compositor, and we want to spread that knowledge a little bit, and then we want to talk about looking forward, sort of like how does this interact with Blink, and how would we like to see this interact in the future? Because I think this is the direction we're going, and it's important for reasons we'll get into. So anyway, I'm Tom Wiltzius. I'm a product manager on sort of like the various sprawling Chrome graphics projects.
Yeah, I'm Nat Duca. I hack on performance and graphics and things.
Yeah.
I make a mess of things.
Right.
But yeah, I mean, we've been hacking on graphics for a couple years. We started trying to make WebGL and Canvas work on the web, but then this whole mobile thing happened.
Right.
Which is like kind of a pain.
So now when we talk about graphics, we're talking about core rendering performance, and this is what has been taking the entirety of our attention recently, and is likely to continue for a while to come. What do we mean by core rendering performance? It's the stuff on the screen, right? Like these are very fundamental interactions in a web browser or in any application platform. You want to be able to scroll fast. You want to be able to animate fast. And by fast, we don't just mean, there was a question about latency earlier, we don't just mean high frame rate, good throughput. We also mean that on a touch-based device, you can really get that page to stick to your finger, or you can get that button to respond as soon as you press it. And so we've sort of expanded scope to look at input latency and that kind of thing as well. Because on weak touch devices, i.e. mobile phones, this is the only way to sort of combat jank in the platform. And Adam had his sort of keeping up with the Joneses thing earlier. I mean, this is exactly where we're feeling pressure, right? The rendering performance side of things is very unattractive when compared to native mobile platforms, and so we're trying very hard to sort of catch up.
Yeah, and like, just to hit the, like, if you're going to Canada and you're planning for like the Canadian National Exhibition, like this site is heinous. Like open this, all of you have laptops and try to scroll it. This is like does not stick to your finger.
When we talk about jank,
it breaks all these
rules. This is like a classic example.
Right? Actually, also Inception Explained is pretty terrible too.
Yeah.
We had this debate about what's the worst on the web, and these were right up at the top of them. Paul Irish actually gives a talk on how to make these not suck. But that's by modifying the site. And of course, we don't want to be doing that, right? That's us failing as platform vendors. Now, we have a hard job, so it's understandable that we'd mess up here and there. But if we succeed at what we're doing in this room, then all of those sites should be really awesome just right out the door.
Yeah.
And we've been working, often not very visible to the Blink world, on some special sauce that gets us there.
Yeah. All right. Well, so let's investigate the special sauce.
Yeah. So the root of all evil, original sin, is rasterization performance. So this is a graph that we did about a year ago, where we took all the sites on the internet, well, actually like 3,000, and we timed the 3,000, a gazillion, whatever. Some number of sites. Numbers. This is on a Nexus 10, and it's the time to take a 200 by 256 square tile and rasterize it. Now you can see some of them are a millisecond or two long. There are 20 tiles on a screen, so even that, 20 milliseconds, right? Some of them are heinously long, 40 milliseconds, right? The Verge.
Yeah. So like one of our fun stats is that if you load, it varies from sort of time to time, but currently one of the worst sites for us to render is theverge.com, because you get tiled box shadows. Rastering all the content you need to display the desktop site on a Nexus 10 takes like 500, 600 milliseconds.
I mean, that's in real time, right? And it's not like you're descheduled.
And it's not like you only pay that once for reasons we're going to get into.
Yeah, it's like all the time.
Yeah.
So go to The Verge, too, and try it out and see if it's good.
Yeah.
This is the root of all evil. And so we have two pieces of sort of core tech that we bring towards solving this problem. The first is Skia pictures or display lists, and the other is going to be layers. I want to show you Skia pictures in some more magical about tracing features that Philip Rogers and a bunch of other people have helped build. This is google.com in a display list form. And we've got all of the operations in google.com here. And here are the costs of all the operations. And I can sort of toggle back and forth, and you can see this is how Blink draws the page, right? And you can sort of sit there going, okay, well, what's that, right? So, you know, hands up, how many people think it's the image? Google.com, right? Okay, and maybe that's evil of me to even ask, but it's actually the white. That. So rasterization is hard because you touch a lot of pixels. And so just the raw fact of touching the pixels is often a problem. Now, sometimes you have a big old drop shadow and, you know, it's got permanent noise on it, blah, 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 and then it's expensive. But sometimes it's just the raw pixel area. The other trick we bring to the recipe of jank busting is layers. I think most people know this. This is Gmail with layers. So again, more special sauce and tracing. You can see we've taken the conversation list, blown it out to a layer. You know, we've taken the chat mole, the top nav. All of those are layers. When you take that, that allows us, and you break your site up in that way, then we can move the page around without repainting. And the repaints cause the raster, which cause the death. Yes. And we don't want that.
Yep.
Technical term.
Right.
All right. Tom, tell us about how it works.
Yeah, so this really doesn't just concern Blink, right? Like this is really has implications all up and down kind of the embedding layers. So really briefly, it's important to note that there is a lot of work that goes into the layers kind of both below the renderer and above it. Specifically, the renderer and the compositor spit out a lot of GL commands. We have a sort of virtual GL platform. You can kind of think of it as across every operating system that Chrome ships on. It's backed by real GL drivers under the hood on most operating systems, but on Windows we use Angle, which is a library that converts GL to DirectX. And the GPU process in Chrome kind of is responsible for actually mediating access to the physical device because you've only got one. So it sort of shares
the internet.
Yeah, between all the renderers, et cetera. Above, there are a couple relevant things happening in the browser. One, this is where input comes from, right? At least for now. And two, when we're actually on the output side, we're moving to a model where not only do we composite the web contents and use these sort of layer tricks that Nat's talking about, but we do the same thing for the browser.
Yeah, I mean, so we're typically, as especially Blink and WebKit hackers and so on, we think of the web page and then the Chrome, right? And we draw the web page, and then there are those guys in Mountain View and some other places that draw the Chrome.
Right.
And that's a nice deconstruction, except that touching the page, touching the screen is really expensive, and so if you actually unify the rendering of the entire stack into one rendering engine, which you can call the Uber compositor, more technical terms.
Yeah, then you can get some really nice performance wins. This is also going to provide dramatically more flexibility in the Chrome or other browser front end in the future. So like the kind of Chrome OS window manager is all based on this, but we're moving all the platforms to it. A lot of my time recently has been going to trying to get Aura up and running on Windows. Aura is a word you may hear thrown around in the next couple days, and that refers to sort of like that whole, we use it a little loosely, but it means sort of like a browser compositor and sort of the associated window manager, et cetera. On Windows, that means like we're drawing all the controls ourselves rather than using like native widgets, et cetera.
And making this switch is crushingly difficult, but the payoff is performance.
The payoff is performance and also developer productivity, right? Because like Adam and Eric were talking about the importance of being able to work on this sort of virtual platform before and not having to worry about platform differences. Like imagine working on the Chrome front end, right? Like that's not even close to true now. But with Aura, down to GL, and we provide this sort of virtual GL layer across operating systems. Everything can be platform independent, right? Because like we have our own view system, we have our own UI toolkit, everything. So this is outside the scope of Blink, but it's important to understand that these things are all kind of tied up together now.
Yeah.
So anyway, that's an aside.
The more you know.
Back to the renderer.
So when we pop back down into the renderer, I say this all the time. So, you know, when you get a big piece of software that's only job is to render, you run out of words.
Yeah.
I think they're like, I've come up with 5 maybe for drawing, but you run out. This is our current set of words.
Yeah,
we use these imprecisely.
We do, but we try to be careful with them because it is so confusing. So we're gonna use these in the rest of the talk. So we thought, you know, little vocabulary primer up front.
And then we'll not use them right.
Right. We talked about painting. Painting in the sort of old software path in WebKit was sort of indistinguishable from filling in pixels in a bitmap, right? But now we've decoupled these concepts. Painting is recording commands into that display list that I was talking about earlier in SK Picture, and we say rasterizing for actually executing those commands to fill in the pixels on a bitmap. We still raster in software. Compositing is when we actually take all the bitmaps for the different layers and we smash them on top of each other to make a screen image, and browser compositing is just that with the renderer contents plus the browser UI, and that's all the Uber compositor stuff we were talking about before.
Stuff,
lots of stuff. So anyway, this is uninteresting, but it's, you know, context.
Yeah, impulse-side painting is actually a lie. It's really multi-threaded rasterization, if you've heard that. So right. Anyway, but what we thought we'd do next is talk about why a lot of people come in, they're like, oh, this is huge. What is this doing there? So we started back in yesteryear with sort of this ultra-simplified timeline of the internet. And you do a bit of JavaScript, and then you do some painting, right? You'd scroll the page down, and you'd have to paint the exposed area. And then maybe you had a canvas on there or a video, and we'd have to smash the web page and the video layer or the plugin or Flash or something, smash them together, make one picture, hand it to that GPU stack. Then mobile came along, and it kind of became like that. And they wouldn't let us quit. Or, you know, go play in our little sandbox.
Right.
Yeah. So they made us do more work.
So,
and
so
James
we tried
R.
to paper over this, basically.
And James R. was a hero and sort of helped us get us to this world where we have this compositor thread. Now, a bit of trivia, we call this the impl thread, and you'll see that. And that's because we ran out of those words that we mentioned. So we couldn't come up with a word because render was taken, and composite mean several things. So we had this compositor thread. It receives the scroll events before WebKit does. It looks at the layer tree, the compositing tree, and if the scroll operation being represented on that input is representable as a translation of layers or a scaling of layers, it does the operation right there. And
then
Blink,
asynchronously it can
tell Blink can continue to have a party doing float layout.
Right. So I mean, we've talked about main thread jank kind of throughout the day, right? And I hope you're sensing a bit of a theme in all of these talks, right?
I'm the grumpy one. He's cheerful.
I mean, this whole system is basically designed to cope with the fact that the main thread can be tied up for unpredictably for arbitrary amounts of time.
I mean, and it's not. I mean, I've shown
doing
this,
any number of things.
I've been kind. Paint raster taking, you know, 25 milliseconds is like really generous.
Yeah, but you know, JavaScript could run arbitrarily long, but at least that's under developer control. Layout can run arbitrarily long.
We see second-long delays. So we're like, okay, this is great. We shipped this. This is what we shipped when Chrome Android came out.
And it like kind of works.
And it was pretty good. And like there were people in that ecosystem that were less angry at us, which is always good. But there were 2 big sort of things that we wanted to do further. One is those paints are still big. And so anytime you'd scroll down and expose new area, we still had to do this big old paint. And it would be, if we scrolled twice, then we'd be still waiting for the first paint to come back. So that kind of sucked. And the other thing was, we weren't making the right layers. If the layers weren't made right, then you know the ship doesn't sail. So we did this thing called impulse-side painting, which is a lie and really is multi-threaded rasterization. And what that does is it moves the painting, it splits it in half into recording of the Skia pictures and rasterization of the tiles out of them, and does it on a raster thread. And every time you scroll, the system's recomputing which tiles to do for that frame. and then we composite what we've got. So this actually gives us, we think, slightly better performance.
I mean, yeah. So like the key thing here is that we now have all the information in the compositor thread, which is, unlike the main thread, sort of responsive. It's not maybe guaranteed, right? Like it's totally possible to miss a frame boundary, but like it's under very tight control. So we have enough information recorded in these SK pictures and in the layer tree that gets what we call committed to the compositor thread, that we can sort of recreate the world as needed. And this is very powerful because it means that, again, in the presence of main thread jank, we can just sort of keep painting what is now potentially stale content, but at least it's like kind of sane. Whereas before, because the painting still happened on the main thread, if we ran out of rastered content, then we checkerboarded, right? Checkerboard is another sort of vocabulary term, but if you use this term for Android and you do a fast fling, and you see just like blank, that's because we don't have the content rastered. We can still move the viewport around because the compositor thread's jank free, right? But like no content, so who cares?
Yeah, you've all had this happen.
This like,
scroll really
and this
fast.
sucks. This is the problem.
So the way that the latest and greatest magic works is we have a sort of distance field and a velocity field that we continually maintain. And you could sort of imagine it visually like this, where every single part of the world has an estimate. And we dice up the world in these little tiles. And those tiles have sort of a velocity estimate. And from that, we can figure out, hey, when will this be on screen? And, we can look at, say, oh, this tile needs cat.jpg. So probably if we're going to paint that, we should go decode cat.jpg. And, maybe we can even fetch it, right, in this sort of hypothetical world. And also, on top of that, you can build in this notion of like, hey, if the user really scrolls fast, you're going to go to somewhere that you didn't predict. Instead of showing them nothing, why don't we show them something blurry? Because those raster times we showed at the beginning, those are proportional to the area of, they're highly impacted by the area that you paint. So if you paint 1/4 size, it goes faster.
And then we can paint a quarter size in terms of sort of like pixels that actually get rastered to, but then we can scale really cheaply on the GPU to fill in the same number of pixels.
And then you can turn off things like anti-aliasing and high quality image filtering and do all of that. And the whole idea is you can use these velocity estimates to figure out, okay, given the urgentness or non-urgentness of the tile, I can do a good thing, I can do a cheap thing, I can do a mix of both. And that's how the latest Android builds work. One of the big takeaways for that is this. We love thinking about the fold, right? Is the image below the fold? There is no fold because there's a continuous distance field, which is obvious. And so we want, one of the things that we hope to do, if it proves to be performance effective, is to get the compositor's sort of brain understanding of this velocity field pushed back to Blink, so that Blink can then use some of this to say, oh yeah, I got some CPU time free, I'll lay out that thing that's high priority because that's probably coming.
Yeah, exactly. And sort of like deferral is a key to how we've tackled the rasterization problem, and we think something like that is probably what we need kind of elsewhere on the platform too, but we don't know, and this is kind of what we want to talk about in the next couple of days.
So, during this, I've cut away to pictures like this a few times where you see something that looks suspiciously like about tracing that James showed earlier, except that there's a picture in here, and there's like full recordings. So this is the frame viewer. It's Chrome's frame viewer. It's built into tracing. It's just more checkboxes that you can check. We could probably talk about this in a breakout, but this is a really great way to fit some of this in your head or be like, I think I understood, but let me check. So it's there, give it a try. It's how we understand things.
Yeah, it's actually hugely useful in trying to understand how this whole architecture works. And we're going to do, I think, a breakout session on this tomorrow morning, if there's interest.
We'll find some time and do something. I think there's interest, right? But this is how we stay sane and how we refine the architecture. So I think it's great if everybody else tries it out too. That's about it.
Okay, so in conclusion, how did we end up where we ended up? We were dealing with a set of constraints. Some of these are here to stay, some of them are not, and that's going to inform what we're going to talk about next, which is what do we do next? Painting is slow. This is more or less here to stay. There are
See, we got the
more
slide wrong. It's
radical
rasterization
ideas.
is slow.
Yeah, it's actually rasterization.
Yeah.
Well, no, I mean, sometimes recording is slow
but this
too.
is where it gets hard.
We do have some more radical ideas about what we can do about this, but they bring with them new challenges. Texture uploads are slow, so if we're doing all this rasterization in software, in order to actually composite these layers on the GPU, we need to upload the bitmap as a texture to the GPU first, right? This means that can be a substantial amount of overhead if we're not careful, and particularly on like memory bandwidth constrained devices. Remember, mobile phones.
Like 1.5 milliseconds per upload times 20 per frame.
Right, and even on desktop platforms, this hurts us often too. So one of the things we've been looking into aggressively here is how can we do so-called zero-copy upload on unified memory architecture GPU systems. And we basically need support from the OS and driver in order to do this. We nevertheless think that it is much better, and we're kind of going that direction on platforms where we have more influence. But I know there are a lot of people here from Intel and Samsung and others.
Please help.
We would love to see sort of like improvements in this area, and we would love to talk in more detail about how we can make that play nicely with the rest of Chrome's architecture if you're interested. The main thread being janky, I mean, I think this is something we all wish wasn't true, but it's like, again, the whole system is designed to cope with that right now. We fear that we are reaching the end of what we can sort of cover up.
So for the last 2 years, it's been go to the GPU guys. You know, Tom and I are GPU people by training, and we've done a lot of jank busting outreach. And the reason is because the compositor's been messing up so badly that we were to blame, essentially. But
Yeah.
we're reaching the end of that. And now it's time to start giving back the main thread to developers, and also just giving the main thread back so you can get more power. So we're toward the tail end of the GPU extravaganza. There's more work to be done, but the next round of things is really, more main thready.
Exactly.
We've talked about this scarcity problem of the CPU several times. It's come up, but we amplify that message heartily.
Yeah.
The CPU, what was that stat you're telling me about with the when scrolling?
Oh, sure. I mean, so on like low-powered Android devices, so this is something that was, high-end 2 or 3 years ago. Right now, just scrolling the page, like with the compositor, no Blink code running even, takes almost 100% of our CPU utilization, which means as soon as we need to raster anything or run layout or whatever, like it's game over. Like we're in really bad shape. This is a problem because these phones, this is going to be what most of the world is using in the next year or two. I'm like, yeah, like if our platform isn't up to it, then we're in trouble.
So, want me to do LCD?
LCD text. This sounds so small
I got
compared
a really
to the other
important
things,
thing to
but
say. It's this, right? It's
yeah. So one of the sort of big areas where we've been looking for improvements is in sort of improving the decomposition of the page into layers. So this is particularly obvious in scrolling cases where previously we just sort of threw up our hands and said, this is too hard, I'm going to re-raster the whole thing every frame. So like overflow scroll divs or something. And in these cases, all this architecture, this only hurts, right? Because now you not only need to pay the raster cost every frame, you need to pay for the texture upload every frame too, plus the overhead of the composite, which is minimally going to increase latency, blah, 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 blah. Anyway, Ian Volek and a number of other people in the Waterloo office have done a lot of really good work trying to improve the situation. And they're actually almost done, which is cool and means that if you, say, take out your high DPI Retina MacBook Pro or your Android phone, you'll see that overflow scroll divs work really well. And we can now respect the background image property if it's fixed in position on Android, because it doesn't totally break the user experience.
But this only works when you have a Retina, and that's because LCD text, it's really hard. Now,
well, in the general case, it just requires way more GPU memory than we're willing to give.
We have tried everything that we can think of. We really are coming to the end of that push to try to make LCD text work in the Chrome stack.
What is LCD text?
What is LCD text? Sure. Web browsers came from sort of doing text layout, right? So text is sort of important on the web. And one of the big things about text is how do you anti-alias it, right? And if you anti-alias it, some ways it looks nicer than others. Microsoft has a technology called ClearType that does sort of basically this, and it's been brought to other platforms as well. It takes advantage of a sort of kind of brutally simple fact that the color pixels on LCD displays are laid out in a predictable order so that you can get smoother diagonal lines by using only the red or only the green or only the blue pixels on a given pixel, so you effectively get sub-pixel anti-aliasing. And this looks really nice as long as you're not one of the people who has color fringing issues and it looks terrible.
Yeah, but the TLDR is to do this you have to control every color channel on your image, and this isn't very compatible with a layer decomposition unless you triple your memory requirements or you do some magic that we really haven't been able to do.
Right. And
so the direction we're heading is to sort of like on some platforms like Android declare defeat, not do LCD.
We've never done it
on Android, but also we talk about changing that elsewhere, Windows eventually.
And again, we want to simplify the configuration matrix because we're running different things, different places now, and this is painful for development. It's painful for content authors. This is not good. But the thing that's holding us back in many cases is actually this very mundane thing. So we're kind of wondering what to do about that. For what it's worth, Microsoft has dropped ClearType support in Metro IE 10.
Yeah, I mean,
maybe I think this is the direction our peers are going.
Rather than try to
Firefox went with the triple memory thing.
Don't take this discussion as we want help on this. It's sort of like we think we should do other things instead and make the rest really awesome.
Yeah.
Like this.
Right. So okay, that whole architectural story of evolution that we just presented, this is true today on Android. It is not true on our other platforms. We have this like crazy configuration matrix where depending on whether or not you've got a GPU, depending on what operating system you're on, and depending on whether or not you have a browser compositor, we have various features turned on and off.
Success here is
a
green.
Nightmare.
This should be green.
Well, we want to delete some of these configurations entirely. So we're spending a lot of time and effort right now. I mentioned earlier that a lot of my time has been going to bring Aura to Windows. We've been spending a lot of time and effort trying to get sort of one top to bottom rendering architecture, including sort of the GPU bits across every platform we ship Blink and Chrome on. We think this will be great for productivity all across, certainly our team, but across the whole project. Like, it is way too hard to make changes to many parts of the code base right now because you need to test in so many different configurations, and we don't have the resources to test well.
Yeah. You can take a peek at this on if you look for Chrome GPU on the Goog, you'll find this. And it's instructive just to understand.
So
the scale
okay,
of that
like
challenge.
that's hard. That sucks, right? We're working on that, but it means that while we're doing that, we can't, like, it's very difficult to push the platforms that are suffering from performance forward even more, right? Because that just brings everything further out of sync. So jank busting needs your help, right? Like it is.
Please.
As I mentioned before with the layer thing, we're getting to the end of where there are easy wins in improving the layer decomposition. We've sort of done most of the obvious ones. So the question is, what's next? Like, how do we get another kind of big step forward in terms of sort of user responsiveness? So we have some ideas.
Yeah, I mean, and this is, constantly evolving, but I thought we could start by talking about what we've been doing and what we got folks doing right now. We already mentioned UberComp. The intent here is to speed up both raw graphics throughput and reduce some technical debt in maintaining all the different browser looks. We have a really we have 3 different image decoding systems, all of which are done and obsolete and in progress. Especially on a high DPI Mac, you become bound on image decoding performance for no good reason whatsoever, except that the new thing isn't ready. So we're working on that. David Reevman is going to save us. One of the neat things that should happen out of that is that we will decode, for example, when an image is highly shrunk on the page, we'll decode and use the memory exactly for the layout, the actual size of it visually, rather than the size of the original asset. So for example, on pinch zoomed pages, you'll get much better memory footprint and performance. There's some cool stuff there. Layer maintenance, sort of recalc style, compute compositing requirements, that's come up several times as sort of a hotbed of fun. And squashing, sort of dealing with layer explosions, culling where you have like a big mail list. Imagine you have a really tall list of mail. Each one is a layer. The compositor, you can hand all those to the compositor, but then all the things that do the transformation of that are going to run long. So when they're ridiculously off screen, 3,000, 8,000 pixels off screen, don't even tell us. There's no point. And so that's another area of active awesomeness.
Yeah.
The folks from Waterloo team, Ian Volek and Glenn Hartman and company are working on that. Many of external customers and also some people from Blink often taken about tracing recording, especially as they get used to the system and go, everything's happening at the wrong time. Your inputs are overlapping your rendering and your thrashing threads, and it's all wrong.
Particularly on low core machines.
Low core machines, and particularly for pages
again,
where you like do finger-based dragging and it's all JS driven. So I mentioned like Sencha apps as an example. We know that this is bad. It's a really scary problem. This is the path of a touchdown. Actually, it's the first touch move event after your finger goes down, and what it flows through in Android.
Every one of those columns is a thread,
except for one. And this is like the new one that works better, and the existing one is a bunch of if-defs. And of course, this is all if-def code, Android specific. And so one of the big projects right now is to clean up both the input stack to have an architecture rather than be a bunch of if-defs, and implement this thing called a deadline scheduler. Really TLDR, the deadline scheduler sits there and goes, hey, this is the beginning of the frame. I should probably be done by about 16 milliseconds from now. Okay, I should probably run RAF. I should probably process some input. Maybe I can paint for a bit. Okay, now I really, really, really need to draw, and it draws. That's the deadline scheduler. The current one does not think like that, and so it does idiotic things. Brian Anderson is working on this heroically. Give him a pat on the back if you ever see him. He's got a tough job.
Actually just landed on Android today.
Yeah. And it won't regress.
It won't regress at all.
So this is really hard. I wouldn't suggest external contributors sort of jumping in on this. It's messy, it's moving, it's got a lot of pieces. Better just throw bad cases at us. We'll sort of try to cope.
Yeah.
Stuff that's more productive to get involved in is some areas here. Do you want to talk about some of these?
Why don't you talk through the first couple, and then I'll talk through
we often joke that we're running the first version of a lot of our code, right?
Yeah.
Stuff that got written just enough to pass the test, and then we like shipped it. This is a great area for like looking for performance, looking for us calling malloc in a tight inner loop, stuff like that. We really do that. We mentioned texture upload. You've seen us get a lot of mileage out of about tracing, telemetry, benchmarking. That's all done sort of in spare time. So anybody who wants to contribute to that is really welcomed. One thing that we talk a lot about is a paint storm. And I actually want to show you what we mean by this. If you pop open DevTools and you show paint rectangles and you scroll, a paint storm is when you're scrolling and the page turns red from repaint rects. So WebKit is sending a whole bunch of invalidations and we're repainting. There's no way that the compositor can perform well in a paint storm. Our whole architecture is based around this principle that those layers will stay mostly unmutated as you scroll. A lot of paint storms happen by accident, not through the actual page changing, right? This page isn't changing here, but there's constant full page invalidation. Taking a page that you see just when you're browsing and figuring out why that paint storm is happening and helping us eliminate it would go huge strides in making the platform feel smoother.
Even just reporting these as issues. Right?
Yeah, or just reporting
useful.
it. Yeah. And finally, we have lots of people out in the real world who do that web dev thing, who make their site better, and then it regresses. And they say to us, well, how do we test for this? And we sort of throw up our hands. So medium term, there's plenty more. Tom.
Yeah. So again, this theme has come up several times today, but dejanking the main thread is huge, right? There's kind of a big question when we're thinking about what kind of content we want web developers to be able to author really effectively, particularly on these weak CPU platforms. The biggest issues right now are that there's a lot of work that the browser does on your behalf that's unpredictable if you're a web developer. And this happens all over the stack, but there are a number of ways that we can make this more predictable, and that will go really far. One is dejanking the main thread. Another is we've thrown around ideas. This came up on BlinkDev for trying to, in some way, encapsulate or sort of control the size of layouts and paints, so that as a content author, you can say like I'm going to move some stuff around in here, but please don't do a global layout.
Yeah, so this is that paint storm and layout storm. So
right.
More of that. We want to avoid that.
But then we think there are other ways that we could attack this too, like with some sort of display optionality, right? This would go a long way towards making the platform feel more refined, because as a developer, you could put in cheap to raster placeholder content.
This is like, hey, I
call
just
that mandatory.
Put in this big 18,000 pixel wide JPEG,
right.
But you're welcome to put up a loading, spinner there.
Or just don't fill it in, right? Like there's flexibility we could expose here that would be very, very powerful. That again, a lot of other platforms have seen used to great effect.
Yeah. So our platform is we render everything all the time, and that stinks. The final one. This is a cool spreadsheet that was built out of the neat what properties are hot thing. And what we did is actually Paul Irish did this. He color-coded each one of these by the invasiveness, meaning if you mutate this style, it will cause this kind of thing in DevTools. So if you mutate width, it's going to cause some layout to happen, right? Or if you change the color of something, then it's going to cause a paint. However, if you mutate opacity, that's going to go mostly directly to the compositor thread, and should be a little less batter. This is a really cool way of thinking for developers, and I think and this is how our web dev team is outreaching to developers to try to teach them how to make things smooth. I think we need to sort of internalize this back to our world and go, what does this mean? Is this like change element.style to like you're about to screw up your performance.style equals,
or like element
whatever.
dot please don't animate this property.
Yeah.
Dot whatever, right? Because trying to animate any of these, you're
going to kill yourself.
You're going to kill yourself,
do.
right? Because there's no way that, again, on a weak device we can keep up with the recalc style, relayout, re-raster, re-upload the texture, recomposite within 16 milliseconds.
Yeah,
I don't see it happening.
So the wrap up though is our grand challenges. These are things that I wouldn't encourage attacking right away, but we are all thinking about in the sort of formative stages.
Yeah.
I believe Eric mentioned this. Sort of, we have this painting system that was heavily influenced by how Core Graphics draws, right? What would this look like if we used Skia Pictures throughout the process? If a text run got drawn last time and it's still there in the exact same form, maybe we don't have to regenerate the whole thing in terms of Skia. Maybe we can save it off and just say, yeah, it's the same. Everybody asks about using the GPU to render. Why don't you just send these all down to the document as drawing commands? Yeah, it's an awesome idea. It would be great for this slideshow, because this slideshow is a couple text runs, a white background. Not so good for this. This is a lot of different drawing commands. So the GPU won't do so hot on that. And the other piece there is the GPU is not actually idle. Our GPU just drawing these textured quads is already pretty darn full. So we want to do this. We really do. And one of the things that we want to try is identifying content-specific opportunities to use the GPU. For example, looking at this and going, yeah, that's an easy one. We'll do that with the GPU. But then looking at this and going, no way, dude. We're going to do this with the software.
Yeah, I mean, basically, this moving to doing drawing on the GPU is a huge change, and it's riddled with trade-offs.
Yeah.
For instance, some of you may remember when we shipped accelerated Canvas 2D. Some things got a lot faster, some things got a lot slower. And that overall, we decided that was kind of worth it. But like that's kind of harder on the web, right?
Like there aren't pages that don't use HTML. I mean, maybe there's like one that uses it's just a full screen canvas, but the trade-off is a much more strenuous one to make because everybody's hitting the real rendering path. So-called.
Yeah.
So,
it's fraught with peril.
If you want to
so
chat about that, we'll chat later.
we welcome sort of data and investigations. We have been a little stressed out and not have had time to do this.
But attack the first stuff first. Like really, if you attack the accelerated painting, it's cool, but please attack the simpler stuff first because there's a lot of win there.
Yeah.
I really do mean that. Like this is the sexy hotness, but it's also the hardest, and it's a big social problem in addition to a technical problem. The final one, just to mention, is the compositor thread kind of breaks the web, right? We scroll the page without ever telling JS. We do things that you just can't see. And some people don't like this, and it makes making certain kinds of effects impossible or very hard.
Right. I mean, so there is a whole class of application that the only way you can write it right now is by getting JavaScript involved on a per frame basis, right? Now, we have a couple options if we're going to sort of acknowledge that class of application is something we need to support. We can totally dejank the main thread so that RAF runs, request animation frame runs every frame on time, and everything is under the developer's control to not run too much JavaScript and not perturb stuff so that it causes long layouts, etc. Another idea is that we could expose the compositor thread to the platform. If you've heard of element proxy, it's kind of what that is.
I mean,
we don't know what the right answer
speculation.
is. But
we're just graphics people, but this is
we
another
would like to
challenge.
talk about these things in the coming day and a half.
That's it, I think, right?
Yeah, that's all we got. We were going to leave time for questions, but we
totally have
over.
We have a half-hour break here. So.
Oh, Max says we have time for questions, so we welcome them.
Thank you for putting up with us.
Yes, thank you.
And questions.
No one?
We've stilled the room.
The Chrome of Chrome, like the browser UI, will be driven by what is currently just a second copy of the Chrome compositor library. The Chrome compositor library originally was in WebKit. We moved it out to its own kind of place, and we just use two of them right now. One for the browser UI, one for the web contents. Uber compositor allows us to use one. So the renderer produces its sort of list of render passes and the associated sort of quads that represent content, and just passes that whole tree sort of to the browser, which combines it with the browser UI.
So it's a forest. Basically, you have the browser is a tree, and then a tab has another thing in it, which is essentially a squashed layer tree down to what's called quads. And Corner James R, if you want to know it, because he'll love to explain it to you.
Yeah, and so I mean, your question,
right,
like, is the browser UI going to be drawn by Blink? I mean, the lines are blurring here, right? And that's kind of part of the point we want to make is, like, no, it's not going to be drawn by Blink per se, because all of that is still going to happen in the browser process. But like, these things are now very tightly coupled for the reasons we just explained, and specifically, it means that performance of the browser UI and performance of the content area is very, very tightly linked, because there's sort of one composite pass for the whole thing, which means that if we're not careful, web content can make the browser unresponsive, and the browser can make web content unresponsive. And this is kind of scary, right? So it sort of it further increases the importance of keeping the compositor thread jank free, and that's why we think that as an architectural concept is probably here to stay. Yeah. Sure. So
imminent.
Yeah.
I mean, this is
we don't know about
my
Mac.
ideal.
Yeah. So the question is, we mentioned switching to Aura on Windows. Aura is again the sort of browser compositor. And what about other platforms? On Chrome OS, we already use it. It was built for Chrome OS originally. On Android, we have, it's not Aura, but it's a very similar model where we do have a browser compositor. So that's kind of already there. And like UberComp is still relevant there. Windows, we're trying very hard to move right now. It is hard. Linux is also in the pipe. We're hoping to release first dev channels with Linux Aura within the next few weeks. We don't have plans to move on Mac at the moment. We would like to see the sort of embedding layer move more in line with the other operating systems, but I think we're less certain how to do it there. Do you have anything to add?
I mean, I think the key thing, if you look at that dashboard, it may be useful for you. UberComp is one of the columns here, but there are several others that you really, probably as a web dev care, or there are several others that we are tracking sometimes more aggressively. So for example, getting the thread on everywhere is very important to us. Then getting impl side painting on is also very important to us. And I think after that, there's things like one frame latency that we really want to move forward.
And that's the scheduler.
That's the scheduler thing. Because those allow the content that people create to behave predictably on all the Chrome family browsers, or all the content family browsers.
We think this is very important from like a web developer standpoint.
Whereas the UberComp stuff is driven by several other concerns. And
that's more like our productivity.
Yeah. So anyway, I mean, great question. If you want to know more, you could talk to Tom.
Yeah, I will say, I don't think there's anyone from NVIDIA here, but so we're trying to move on Linux right now. We haven't turned on forced compositing mode or threaded compositing on Linux, but Aura is going to sweep all those things along with it. So some sort of dramatic changes are coming to the Linux port. The reason we've held off is because we've had a heck of a time with the driver landscape on Linux. So if any of you work on Linux drivers or work for hardware vendors who provide Linux drivers, like, we would love some help with that.
Please fix your...
There was a question over here. Nope. Yeah, Dirk.
So it's a couple of questions.
Yeah.
In terms of tuning for these different things and looking at these different tools, have we found that sort of if you tune your websites for the slowest device, then you get the others for free? Or is it a case of like you tune it for Uber Compositor on an Android device and suddenly XP performance goes to hell?
That's a great question. I think I'm going to say yes. What are you going to say? I mean, there are some subtleties in that, like, you're probably designing a pretty different website
I would say that
a mobile phone than for like a desktop. So unless the pixels on the screen are really the same.
Assuming the pixels are the same.
Image decoding is the long pole.
If you were trying to do like, show the desktop site on your phone and make that not suck,
Mm-hmm.
The easiest way of doing that is to not show the desktop site.
Right. If you show the desktop site on your phone, there are some pitfalls that, like, image decode is sort of the biggest one, but for the most part, you'll be in pretty good shape.
Well, I guess I would say the two pieces that, and these are things that we've brought out as sort of under discussion or highly hated, the 3 image caches and trying to get them to be one. That's key because it is. And the other one is LCD text, because a lot of people, I've seen so many times where people have tuned on their Retina MacBook Pro, which is not impulse side painting and it's not all these things.
But we promote some of the layers on your behalf.
But yeah, and then that doesn't
work. It makes it way more
on
awesome on those machines. But then if
we
you
need
go
to get
a 1 year older
architecture.
MacBook Pro, we don't do the layer promotion because we don't want to lose the subpixel text anti-aliasing.
It's basically in the interest of the web platform that we get to one-ish architecture. I think that's the really short, and we're not there. We're working really hard on it. But until we get there, it's the answer that you get back is us not giving you a clear answer.
But that's the direction we're trying to move as hard as possible.
I guess the follow-on question is sort of for both you guys and Tony and James from the speed team.
Sure.
Like, in some ways, 4 or 5 years ago, Steve Sauter sort of changed things when he published Wislow and he wrote his books. And he said, here are these 10 things you can do to speed up your website, right? What we're seeing today is that we have this tremendous base of knowledge and very good tools for poking into stuff, but there's a learning curve, right? And it's an expert system, and to understand and interpret things, is it conceivable that we get to a point where we have a Google PageSpeed or a Wislow for Jank for layout and interactivity and things like that?
I think it is conceivable. I think we're kind of far from that point. As you can tell from everything we just talked about, there is a lot changing, and this is just Chrome, right? Internet Explorer works radically differently, and is good at different things. But I think we're starting to see convergence of a lot of the rendering architectures, and that will allow sort of much more targeted performance testing that would let us do something like web page test.
Some stuff that's going on in this front. Pavel and company and DevTools are trying to take the best or the least bad ideas from our advanced tools and
about tracing,
and bring them into sort of a more accessible way. And then you see, so frames view is an example of that, where you get a simplified version of what all your rendering frames are. That's a really good example of taking and sort of waterfalling down the stuff that works everywhere. And you actually, one of the top requests for Firefox DevTools a couple months back was that frames view. We also just saw the layer viewer, so the sort of layperson version of that one that I showed you here, popping up in DevTools. We haven't moved on performance monitoring. So window.performance. Navigation timing. That's a great tool for developers earlier, and it enables things like Steve's YSlow and stuff like that. We don't have any progress on that in the rendering ecosystem.
Yeah, like driving forward web perf working group specs related to rendering performance would be phenomenal. Yeah. We would like to do it, but we don't have time.
Yeah.
I think, yeah.
That's the state of the onion. Maybe someday we'll get better, but anything else?
I will say also we're trying to do a fair amount of developer outreach.
We are the Jankbusters.
We give talks, we do things. I work with DevRel a lot to sort of get the message out about these things. I think if you look at awareness in the web development community about the importance of building your app in a way that's jank-free, it is so much higher than it was a year and a half ago. We gave a talk at I/O a year and a half ago, and people were like, I'd never thought about that before. Like, I'm a web developer. I don't think about frame rates. But now, that's not the response we get at all. I think that's good. I think that's a little bit the landscape moving around us, and maybe it's a little bit sort of some of the evangelization we've tried to do. But I think we need to, I think a persistent thing we hear from developers is performance, and like making this easier, right? Again, that property list, like, oh yeah, but don't use any of the ones you would think to use first, right? Like, this is just a redux of the 10 wrong ways to do something, one right way to do something thing that we've been grappling with for a long time.
One more?
Yeah.
So I never actually seen how it works under the hood, but now when I look at it and I see frame debugging and 60.6 milliseconds, it really starts to look like game development and real time.
Yeah. So guess where all these people used to work?
A lot of us are ex-game developers that.
In a few years' time, we're going to see this page requires that you have at least a chip or whatever.
Yeah, I mean, certainly, I think actually a slightly better, yeah. So the question is, if you start digging into these about tracing timelines, all of a sudden this starts to look like a lot like profiling during like video game development, and indeed, it does look a lot like that. I think actually a slightly more apt comparison is we're really building like a full OS like graphics API on top of 5 other operating systems.
I've said a couple times.
Is hard.
I've said it to some people that join us from the video game industry. We're building the world's most highly distributed game engine. It comes with an editor. It comes with a scene graph. Very few game engines have something like CSS. So maybe we should just delete that.
But so there was a question specifically about also like, are we going to get to a point where we have sort of system requirements for Chrome or for particular pages? In some ways, yes, I do want to see us go that way because I really want driver quality to improve. And I really want to say Chrome's not even going to run if you don't have a GLES conformant driver, like end of story. And we've been pushing a lot into the conformance test suites to try to improve things. But other than that, like system requirements, that kind of thing, that's content specific, right? The sort of dream is that the platform we're providing is so thin and so lean that if you can write a simple application that does really run anywhere you can run a web browser, right? Like that's the goal. Like we want to maintain portability to the fullest extent possible. If you want to build Grand Theft Auto with WebGL in the browser, more power to you. And if you want to say on your site, by the way, you kind of need a fast computer for this to work, that's okay.
All right, have we exhausted
Okay.
everybody? Awesome.
Come talk to us afterwards.
Thank you, everybody, for coming to BlinkOn and listening.